Hey everyone, and welcome back to the channel. Ever wonder how your phone knows exactly what you want to type next? Or how streaming services suggest the perfect movie for your Friday night? The magic behind it all is something called machine learning, or ML. Today we're going to demystify this powerful technology. We'll explore what it is, how it works, and even see how you can use it in your own projects with tools like n8n and OpenClaw. So, if you're ready to unlock the secrets of how machines learn, stick around. First things first. What exactly is machine learning? In simple terms, it's a way of teaching computers to learn from data and make decisions or predictions without being explicitly programmed for every single task. Instead of writing a long list of if this, then that rules, we give the computer a ton of examples and let it figure out the patterns on its own. It's like teaching a child to recognize a cat. You don't describe every possible type of cat, you just show them lots of pictures of cats. Eventually, they learn to identify a cat they've never seen before. That's the core idea of machine learning. To understand ML better, we can break it down into a few key types. The most common is supervised learning. This is where we provide the computer with labeled data. Think of it as a student learning with an answer key. You give it data and the correct outcomes, and it learns the relationship between them. For example, we could feed it thousands of emails labeled as spam or not spam. Over time, it learns to identify new spam emails on its own. Next, we have unsupervised learning. Here, we give the machine data without any labels and ask it to find hidden patterns or structures. It's like being given a huge box of mixed Lego bricks and being asked to sort them into groups without any instructions. The algorithm might group them by color, by size, or by shape. This is super useful for tasks like customer segmentation, where a business might want to discover different groups of customers based on their purchasing behavior. Then, there's reinforcement learning. This is all about learning through trial and error. Imagine training a dog. When it performs a good trick, you give it a treat or reward. When it does something wrong, it gets no reward. A reinforcement learning agent works similarly. It exists in an environment, takes actions, and receives rewards or penalties. The goal is to learn the best sequence of actions to maximize its total reward over time. This is the technology that powers self-driving cars and game-playing AIs, like the ones that can beat world champions in chess or Go. Finally, we have deep learning, which is a specialized subset of machine learning. It uses complex structures called neural networks, which are inspired by the human brain. These networks have many layers, allowing them to learn very intricate patterns from vast amounts of data. Deep learning is the powerhouse behind a lot of the cool stuff we see today, like voice assistants, facial recognition, and language translation. It's what allows your phone to understand, hey, what's the weather today? So what makes all of this work? There are a few core components. First, you need data and lots of it. Data is the fuel for machine learning. Then you have the model, which is the algorithm or mathematical structure that processes the data and learns from it. You also need a loss function or objective function. This is a way to measure how wrong the model's predictions are. The goal of training is to adjust the model to minimize this error, making it more accurate over time. Now, let's talk about how you'd actually implement a machine learning project. The process generally follows a few key steps. It starts with data collection. You gather all the data you need for your problem. Next is data preparation, which is often the most time-consuming part. You have to clean the data, handle missing values, and format it so the model can understand it. After that, you choose a model based on your problem. Are you predicting a category, a number, or finding groups? Then comes the training phase, where you feed your prepared data to the model and let it learn. Once trained, you have to evaluate the model to see how well it performs on new, unseen data. Finally, you can start making predictions with your trained model. Let us make this more concrete with a classic Python example, predicting the species of an iris flower. This is a famous dataset in the machine learning world. It contains measurements for 3 different species of iris flowers: the sepal length, sepal width, petal length, and petal width. Our goal is to build a model that can predict the species based on these 4 measurements. Using a popular Python library called scikit-learn, we can do this in just a few lines of code. First, we'd load the iris dataset. Then, we'd split this data into 2 parts: a training set to teach the model, and a testing set to evaluate its performance. Let's say a canerous neighbor's classifier. This model works by finding the K most similar flowers in the training data and making a prediction based on their species. We train the model on our training set. Finally, we use the test set to see how accurately our model can classify flowers it has never seen before. In most cases, it gets it right over 95% of the time. It's a simple but powerful demonstration of supervised learning in action. For the really exciting part, how can we bring this power into our everyday workflows without being a coding expert? This is where tools like n8n and OpenClaw come in. n8n is a workflow automation tool that lets you connect different apps and services together with a visual interface. Think of it as building with digital LEGOs. It's an open source platform that simplifies running AI models. Imagine you want to build a system that automatically categorizes customer support tickets. With n8n, you can create a workflow that starts whenever a new ticket arrives in your help desk system, like Zendesk or Freshdesk. Then, you can use an OpenClaw node with an n8n to send the ticket's text to a pre-trained text classification model. This model could be one you built yourself or one available publicly. The model analyzes the text and predicts a category: is it a billing issue, a technical problem, or a feature request. OpenClaw handles all the complexity of running the model. The result is then sent back to your n8n workflow. Finally, n8n can automatically add the correct tag to the ticket in your help disk and even assign it to the right department. All of this happens automatically, saving your team hours of manual work. You've just implemented machine learning in a practical way without writing a single line of complex code. This is just one example. You could use n8n and OpenClaw to analyze the sentiment of social media mentions, extract information from invoices, or even generate product descriptions. The possibilities are truly endless once you combine the power of workflow automation with the intelligence of machine learning. It democratizes AI, making it accessible to everyone, not just data scientists. So, to recap, we've journeyed from the basic concept of machine learning teaching computers to learn from data all the way to a practical implementation using incredible tools like n8n and OpenClaw. We've seen how supervised, unsupervised, and reinforcement learning solve different kinds of problems, and how deep learning is pushing the boundaries of what's possible. Machine learning isn't just a futuristic concept. It's a practical tool that's here today, ready to help you automate tasks and make smarter decisions. Thank you so much for watching. I hope this gave you a clear and exciting look into the world of machine learning. If you found this video helpful, please give it a thumbs up and consider subscribing for more content like this. Let me know in the comments what you'd like to learn about next. See you in the next one.